Good evening, sir. Can I hear you, sir?
Can you hear me?
I can
Have
now.
you been talking since? Mr. Samuel,
Can hear you. You said what?
have you been speaking since?
Yes, yes.
We've not been hearing you.
Okay, so can you hear me now?
Yes.
All right. So what I was saying is that what I've said so far is that in our last class we wrote a requirement for our funds to be received, and they will say that these contracts can only receive one ether. Understand? Sorry, ether above one. So anything one and below cannot enter. You understand? They'll tell you not enough ether. You get something not is. So users don't really interact with coins, you understand values. They interact better when you use current fiat values like dollars. Okay. Now we are saying that what we are raising is money, you understand, not coins. And so our currency emphasis should be our unit emphasis should be in dollars. Okay. So now we are saying that the minimum transaction should be $5. Okay, five in USD. Understand? $5. But the problem here is that the the blockchain does not understand dollars. All right. Now, dollar is an off-chain data. Okay. Now, how do we bring in dollar into our contracts? How do we make our contracts to understand dollars? How do we make our contracts to interact with off-chain data? Okay. So that is where oracles come in. All right. Now, oracles are gives your contracts the ability to be hybrid. Hybrid in the way that your contract has the has the characteristics of on-chain and off-chain. That means it contains off-chain and off-chain data. Okay, understand? So that's what oracles does. That's the role of an oracle. You get. So this evening we'll be talking about oracles and interface. All right, I'll be introducing us to oracles and I'll be introducing us to interface. Introduction. So in our next class, we'll be using these guys in our contracts. Okay. But today I want to introduce us to what oracles are, how do oracles affect our our contracts. All right, how we can use oracle is very very important, very very important. Why? Because the blockchain has the characteristics that it does not break. That's one. Secondly, it's, how will I put it, it is okay, it is deterministic in nature. Deterministic in the sense that it knows everything that happens in itself. You understand? It wants to know everything that happens within itself, and so it helps to ensure consistency in nodes. You understand? It helps to ensure consistency in nodes when it comes to consensus mechanisms. You understand? Now, say for example, a node brings in a data, understand, and computes the data. So for different nodes to not have different data, you understand, the blockchain has to be deterministic so that every node will run in the same space, in the same pace. okay, so that every node will not have different data. All right, it will disrupt the blockchain. All right, it will cause what they call Oracle problem. Understand? You get Oracle problem or smart contract connectivity issue. Okay, now the Oracle will be using for this training, okay, and which is one of the most popular oracles out there is Chainlink. All right, Chainlink. Okay, so let me take us to Chainlink documentation. So, all right, so Chainlink has 4 products. All right, so after this class, I will beg us to go check it out. All right, so you can say docs.chainlink. Okay, so we'll go check it out. All right, so Chainlink is a modular and decentralized Oracle network that enables the integration of data and external computation into smart contracts. All right. So when a smart contract combines off-chain, like I said before, and off-chain data, it is called hybrid smart contract or hybrid contracts. All right. Now, I said that the blockchain is deterministic in nature. That means it doesn't know anything of chain. It doesn't know anything of chain. It doesn't interact with anything of chain. You get, and our dollar that we're trying to bring into our contract is something off chain. It's an off chain data. All right. So a brief want to know how it works. All right. So how it works, let me, okay, so like I said, we should take our time and check it out and go read about it. But I'll give us a very brief illustration on how it works. All right. So, all right. So, okay, let me just give an overview of this. I'm not seeing the diagrams. I'm actually looking for, but I'll give a breakdown on this. Okay, so what how these chainlink data feeds work is that it collects different data price that inputs from different nodes, okay, and these nodes collect their data from exchanges. I'm talking about price feed, like collecting the data of data price of Bitcoin, for example. Okay, now they collect different price feeds, you understand, from different exchange, and then they bring back all these different prices together, and then they send it to a reference contract. Okay, they send it to a reference contract, and then this reference contract stores the address. All right, now they aggregate every address together and then send it to this reference aggregator, sorry, reference contract. Now, every there are different nodes. There are different multiple different nodes, and then all these nodes together combines and then send it to a particular node, and that node stands as the should I call it keeper nodes? Okay, node, and then this node sends the price feed, picks a particular price, let's call it an average price, and then send this price to the reference contract. Now, this reference contract is what we use to determine our price. Okay. Now, this reference contract is what we use as to collect price data of a particular asset. All right. So, okay, smart contract will real-time data such as price assets and specialty price. For example, centers. Okay. I'm actually looking for a diagram. I think there was a diagram that actually showed us this. Okay, I think let me use. Think let me data the chain. All right. Okay, so I believe that what we see speaks more than what we hear. So let me use their illustration and then just illustrate it to us. But everything I'm saying is still the same thing. Okay. Okay, so this is what the price feeds. These are the price feed works. Okay, so these are different cryptocurrencies with different prices. Okay, this shows the currency pair, the network, the price. Okay, the deviation threshold and the heartbeat. Okay, either of them, anyone that goes first, and then the asset class. All right, so now we can actually get any of these tokens, their price to our contracts, all right, and then use the price field. Okay, now this is how it works. All right, so now these are different exchanges. These are different exchanges, and these are data aggregators, and these data aggregators are the nodes that get this price data from our exchanges. Okay, so when they get it, you understand, they send it to the Chainlink nodes. All right. Now these are the aggregators, and these are the nodes. These are the aggregators that gets the data from exchanges and then send it to the nodes, to the Chainlink nodes. Now, these Chainlink nodes send the average price. Okay, they send it to these contracts. All right, call it the reference contract. Now, this reference contract is what we developers will be using in our contracts, in our smart contracts. All right. Now, this is why Chainlink Oracle is very important, because normally developers are supposed to fall back to a centralized Oracle where we can get off-chain information, since um, centralized oracles are off-chain. You understand? They are centralized, they are not decentralized. Okay, but getting centralized data, you understand, using centralized data from a centralized oracle in a decentralized platform, we actually, how will I put it, bring to naught everything about the the standard of the decentralized ecosystem. Okay, so if it's decentralized, everything about it has to be decentralized. Okay, so that's why Oracle comes in. Oracle is a decentralized modular Oracle. I say Oracle, sorry. Chainlink is a modular decentralized Oracle. You understand that gets off-chain data. You understand, but it's still decentralized. It brings it and converts it to a data that the blockchain can understand. I don't know if I'm communicating. All right. So that's what this nodes does. That's what this node does. They send these nodes and give it to us. All these things I'm saying just explanation. It is not something that's a rocket science. Like I said, after this class, go and read about it. Go to Chainlink and I'll drop the link. Okay. You go to Chainlink and then you can get your hands on it. All right. So that's it for data feed. Now, one beautiful thing is that Chainlink has um four main features, four main products. Okay, the automation, the data, the function, and the VRF. Okay, so as time goes on, we'll talk about the CCIP and the proof of reserves. All right, but the CCIP and proof of reserves are latest features in the Chainlink ecosystem. All right. So we have the automation, we have the data, we have the function, and we have the VRF. Okay, we'll be using the data feed. Data feed is where we use it to get prices for of off-chain data, off-chain currencies on the blockchain. That's one. Then the automation. Okay, the automation serves as a system keeper. Okay, sounds as a keeper. All right. So the news, what it does is that it listens to events um and they are triggered automatically to execute intended actions within the core contract. That means you can call it and then it says as node keeper for your blockchain. If you don't understand, for your contract, if you don't understand it, no problem. Okay. Um that's for automation. So we have this function. Okay, that's for this automation. Yeah, this automation. All right, we have this function. So what function does is that it helps you to consume off-chain APIs on the blockchain. Remember, I said that the blockchain is deterministic, so it's very difficult for you to interact with off-chain data. So what it does is that it helps us to call APIs. Understand? Help us to call APIs in the decentralized environment. That's what this function does. And then this last guy, VRF, okay, the VRF stands for verifiable random functions. So what it does is that it helps us to generate random numbers. Okay, so we can use these random numbers for randomizing NFTs, for games, for lottery, you understand? And now these random numbers are actually gotten from off-chain. They're actually off-chain numbers, but they cannot be manipulated. That's one beautiful thing about them. You understand? Although they are off-chain numbers, but they cannot be manipulated. All right. So in the course of this training, we'll be using VRFs, we'll be using functions, we'll be using automations, and as many as we can. So for this training, we'll be using Chainlink Oracle as our Oracle. Okay. All right. So now let's see how it works. Okay, let's see how this price guy works. All right, let's see how this price guy works. Okay, so we'll go to docs.chainlink.data. All right, so we'll come to this get started, and now um, they're going to show us an example of how you can actually implement this this data feed in our contract into our contract. Okay, and then you can actually open this in the remis.ide. All right, so we can open this in remis.ide, but for the sake of this class, we'll open it, and then okay, so let's open it, and then let's give it a try. Let's test it. Let's see how it actually works. All right, so I'm going to open it. Now we're not going to be using this guy in our contract. All right, we are not going to be using it in our contract. Okay, you don't just use stuffs in your contract. All right, so you should be very, very careful the kind of plugin and interfaces or whatever you're using for your contract. Very, very careful. So we'll not be using this guy in our contract but for the sake of testing. All right, so we'll be looking at it and seeing how it works. All right, so let's just finish loading so that we'll see how it works. Okay, I think it didn't open the contract. Let me just go back again and open it. Okay, let me open this guy here. Has not opened anything here. Let me just open this guy again. So see, um, so we tried to open the remis.id, the remis they sent us here, but we didn't see anything. Okay, sorry here, but we didn't see anything. So we just have to cover it, close it, sorry, and reopen it again. All right, so we have our contract. Okay, now look at this contract and try to understand what is going on here. Okay, look at this contract and try to understand what's going on here. Okay, so and also Chainlink is also very good at L2 solutions. I think one of our classes we talked about layer ones, layer two, layer zeros. Understand? So um L2 Chainlink is very good at L2 solutions. All right, so we are going to be using Sepolia for this test, and we are going to be getting Bitcoin price in USDT. All right, if we come back to our stuff here, let me go back to this price feed. Now you see that let's say once this Bitcoin price, you understand? Let's say we want this Bitcoin price. All right, so we'll come to this Bitcoin price. Okay, we can see that we have the price here. All right, we have the mainnets. We have the guys that are, I say Oracle, sorry. The networks that is being supported. All right, you have the trigger parameters and the heartbeats. The last time it's updated was updated 26 minutes ago. Okay, and other information that we can get. All right, and then the people that are giving us this price data are these guys. All right. Now, these notes are also paid in links. Okay, these guys are the one running the notes, and they are paid in Link. Okay, Link is the official token of Chainlink blockchain. All right, so you can get um um other informations here, oracles that are running these nodes that are feeding us with this information. All right, so another thing again is that you can get the address here. You can use this address for the price. Okay, you can use this address in getting the price. All right, so now for this is a test. This is a test, so but it's still going to give us the real value. All right, so we are going to just run this guy and deploy. So we're going to be deploying using our Sepolia ETH. All right, it told us that we are going to be using Sepolia. So we have some Sepolia ETH. So we are going to be using our Sepolia ETH, and then injective MetaMask. All right, so I've changed it to MetaMask. So when I deploy, it's going to sorry, something is still loading in. All right, so when I deploy, it's going to pop up my MetaMask. All right. I don't know if you can see my screen. Okay, you can't see my screen. Let me stop it and okay, let me just stop presenting and do it again so that we'll see everything. Oh, sorry, you're supposed to be here. All right, so I'll just deploy this guy and okay, sorry. Can you see my MetaMask?
No, no.
Okay, let me change this guy to all right. Okay, so I can't okay. All right, can you see my screen? So can you see my MetaMask now?
Yes, sir.
All right, so I'm just going to deploy this. I'm sorry, confirm this transaction, and All right, so my contract has been deployed, and now if you can see my screen, you see this blue button here, get Chainlink data feed latest answer. All right, so we are getting the price of Bitcoin. All right, so when I click on it, all right, so I click on it, I'm going to get 617 something 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 something, which is the price of Bitcoin. All right, so if I come here and let me copy it. All right, so this is what they give to us as the price of the current price of Bitcoin. All right, let me just, now you will notice that it's giving us not in decimals. All right, the price is not in decimals, it's just giving us, all right, the price is not in decimals, it's just giving us one number. Let me zoom in so you see, just giving us one number, but we know that, but I know that Bitcoin is in 8 decimals, so we have 61 and 8 decimals will be 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that will be here like this. All right, so current Bitcoin price is 61,750.3183090. All right, so that's how we use price feed to get real price data the from off chain. You understand, from exchanges to our blockchain, to our contract. So okay. Now having said that, we're going to be using it in our contract. All right, we're going to be using um that in our contract. All right, so in our next class, we're going to be putting this in our contract and see how it works. All right, so that's what we're going to do in our contract. But today I'm just trying to introduce us to how this whole thing works, how Oracle work. All right. Okay, the second thing I want to talk about is something I call, okay, it's not something I call sha. It's actually interfaces. Call this one. So I'll just copy this guy and come on, paste it here. All right, so what are interfaces? Okay, so interface enables us to call contracts without um copying and pasting them. All right, works like inheritance. All right, so that's what interface does. Gets, it helps us to use a particular contract without making use of them, without, like, the contract is in 10,000 miles away, and then we can use the interface to use it in our contract without even inheriting our contract. All right, and then we can use interface as um like maps is not like the mapping I taught you, like um structure. Okay, like structure. Okay, structure of a particular contract. All right, so I'm getting the interface of a particular contract, so I'm using the structure of that contract in this particular contract. All right, so, or something like making this part my contract as the characteristics of the contract interface I'm using. All right, that's interface. Okay, so interface have some simple laws. One is that an interface cannot have a state variable. An interface cannot have constructors. An interfaces are like abstract contracts. Okay, interface does not inherit other contracts, but interface can inherit other interfaces. Okay, what else? What else? What else? What else? What else? Okay, interface can only be external. They cannot be private. They cannot be internal. What else? What else? What else? What else? What else? Um, okay, I said that interface cannot have constructors. Interface cannot have states. What else? What else? What else? What else? Okay, okay, that will be it for now. If I can remember anyone, I will tell you as this class goes on. Okay, so um um so interface are written like with the keyword interface. Okay, interface are used as interface. Use the interface keyword. All right. So let's write a contract. Let's write a contract and okay. Sorry, let me remove these guys. Okay, interface are written like this. Interface and you have the name. There's the syntax interface name. Call it interface name, and then that's it. So we can have our functions here. All right, function name, and then external share. External in the sense that it can only be called in other contracts. Okay, and then all right. So this is how interface syntax works. All right, so this is how interface syntax work. Okay, so this is the syntax of an interface. This is how to write an interface. Okay, so other things can be
Double.
added to it. Sorry,
I said with double function.
you can have as many functions as possible. You can have one function. You can have as many functions as possible. I just use two functions for the sake of example. All right, so now your function cannot be functioning in the sense that you cannot write a function like this in in interface. Like cannot write a function like this in an interface where you have something like this and understand. You get your function cannot have something like this inside of it. No, cannot. Your functions are barely just like structures. All right, they're just like structures. Okay, let's use a very common example. All right, let's use a very common example. So let's write a contract for counter. This is a very common example. So okay, let's say we have a contract. Let's call this contract counter. Okay, so all right, so what this counter does is that counter adds, understand, add one to it, like an increment of one, understand, like 1 2 3 and all that. So I'm going to make this guy create state variable. And let's make this guy, let's call it count. Let's make it public so that we can see it. All right, so we'll write a function, call it okay, this increment is going to get an input. Oh no, I'm not having any input yet. So let's call this guy internal. Since we're going to be writing an interface for it. So first of all, why I'm not putting that input is because we are setting up something first. So all right, so let's call this counts plus equal to 1. All right, we understand what this um operator means, yeah? I believe we understand what this operator means. Yeah? Nobody is saying
Sir, please
anything.
remove your mouth. Remove your highlights.
We understand what that operator means, yeah?
What we say there's one equal.
Sure, you can see it now. Okay, so this plus equal to, we understand what it means. All right, so now these are simple contracts. All right, if we save this guy, it's going to save. I don't know why this thing is not saving, probably because of network. All right, so but when we deploy, we can't deploy because when we deploy, we can't see anything. There's no output. All right, this is just a set of contracts. All right, so let's create an interface. All right, this is an independent contract entirely. This is an independent contract. Okay, so we want to create an interface to interact with this contract. Okay, I want to create an interface to interact with this contract. So it's very simple. We said that we write interface like this. All right, so let's do interface. Okay, so according to industry standard, all right, so a lot of developers, so this is how we write name our interface. You can name your interface any name you want to name your interface, but for the standard, you understand, and for easy recognition, either you name your interface. So let's call this interface counter. All right, you can call it interface counter. All right, or you can just call it I counter. All right, so let's call it interface counter. All right. Okay, interface counter, and then so write a function counts. Okay, going to be external. We said it's always going to be external. View returns, and it's going to be returning uint. All right. So what we're saying is that when we are interacting with this contract, okay, the returns of the counter is going to be a uint. Okay. So we'll write another function. So let's call this function increment. Okay. This is external. I don't know why this thing is not, it's not working. All right, so okay, so wrote our interface, all right, and then this is our interface. I just hope this guy is running so that I'll see if I have an error or something. Let's just go on. All right, so I'm going to write a contract to interact with our counter contract using our interface. Okay, so we're going to be using our interface for this counter contract. All right, so let's create our contracts. So let's call this contract my contracts. Let's name it appropriately. Okay, so let's write a function. Call it increments. Increment counter. All right, so this increment counter is going to be counting addresses. All right, so let's call this guy. All right, so we're going to be calling our interface. All right, let me just copy this guy. And then copy this guy. Or let me just write it instead. Okay, so this is where it's interesting. All right, so we are going to be calling the function in our interface. All right, so I'm going to be calling the function in our interface using the dot notation. All right, dot notation is this is our dot notation. We have been using dot notation actually, but when we use the dot push, okay, when we did dot pop and all that in the array. All right, so it's called dot notation. All right, so dot increment. So we are using this guy. We are calling this guy. Okay, so now we've called our increment. Understand? Now this increment is from our contract counter. Okay, we just called it in our interface. All right, and we are calling it here. That means it's going to be using the same characteristics of our increments, the same way this increment works here. That's how it's going to be working here using our interface. All right. So I'm going to write a function to actually get what we've done so that you can see what we've done. Yes, I want to write a return function. So let's call this guy get counter. All right. And then we are getting this guy. So we are going to be imputing address.
Now, please, share you go over this thing again.
Don't worry, I'll go over it again. Don't worry. Okay, so I'm going to be inputting the address because it's the address we're going to be putting for us to get the counter. Remember, our counter is of the type uint, all right? But what we're imputing here is our address for us to get this counter, this increment here. Okay, so this guy is going to be external. Remember, when you're using um interface, it should be external. You turn returning UX. Okay. All right. So how do we write this guy out? Okay. Remember how we how we use the increment here. You understand? So we are using this function here, count. Okay. We've used this function, understand, in this function increment counter. So we're going to be using this function here now in this our interface. Okay. So we're going to be saying that return, and we are returning this guy, this interface. Return this interface, and this interface is getting this counter guy. It's just similar to what we did in our um storage factory. All right, just the same way we we played with our contracts. Understand? That's it, the same thing. And then this counts, and we are calling the count function. All right, so where do we get this count from? Remember, we get this count from here, this function. Understand? This count function. That's it. That's what we are calling here. We're calling the count function. So that this one works like what we did here. Understand? So if we run this guy, I don't know why I think it's network. Network is not working. Hmm. This thing is not compiling. Let me just refresh and all right, so we're going to be using the interface. I'm going to be using interface for our phone me, or we're going to be using interface from Chainlink. You understand? We're going to be using interface from Chainlink, but let's just see how it works. Okay, that's why hence this example. All right. So let's just see how it works. I think I'm having network issues. Andrea is happening to me. Okay, let's see if we have any issues. Yeah, I think I do have an issue. Okay. This a function is declared to be view because it's extension state. Function cannot be get to view state. All right, so let's see if we can change it to pure. see. Okay, so um what else? 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 Can you guys see what I'm doing?
Yes, sir.
All right, so I deployed and okay, so all right, so if I put in this increment, I see I have count 3. Oh, sorry, think I deployed the wrong contract. So by this guy. All right, so our first contract, what our first contract does is that if I click on increments, you see it will be increasing by 5, 6, and all that, and all that, and all that, and all that. Understand? I did. All right, so now I want the same thing to be happening here. So let's say, for example, I copy this address and then I paste it here. Control V, and then I activated this function increment. So if I put this same address here and then understand, it's going to show 9. Right now, if I put another one, it's going to, if I increment from down, it's going to show 10. You notice something very, very interesting is that it continues from where this guy stops. If I put an increment and it shows 11, so if I include an increment here, it shows 12. Now, is the actually deploying this contract. You understand? It's actually using this contract. It's working this contract, but is using this particular contract is actually running on this contract using this interface. Now, why is this guy very, why is it different from inheritance? Like deploying a contract upon a contract, like what we did in FundMe. I say FundMe in simple storage is because these two contracts are not running independently. They are running independently, but they are linked together. Altogether, they are linked together. They are linked together because of this interface that we used here. All right. We use this interface to link this contract and this contract together so that they operate in one particular, should I call it one particular environment. So these two contracts are running in one particular environment, and this environment is this interface here. We use this interface to make these two contracts run in one particular environment, irrespective of the fact that whether this contract is off-site or not, whether this contract is 10,000 miles away or not. With the use of this interface, we can actually run this contract and this contract together. Okay. So normally what this contract does is that it just increments. All right. But what this contract does is that it uses the blockchain. It uses address to increment. All right. So it has its input as address, and then it increments. All right. So when I increase by an address, it shows here. But if I come here, I'll see 13. All right. Now, if I increase here, now they are both of them are two different contracts. This is a counter, this is counter contract, all right, and this is my contract. Now you see that the two contract addresses are different. They are not the same contracts altogether. They are not the same contract. But you see that if I increase this counter to 15 and I come to this count here in another contract, you see that the count here is 15 even without incrementing it here. But if I increment it here, it's going to give me 16. And then well, let me increment this guy here, which is supposed to give me 16. It's going to give me 17. Why? Because of the interface. The interface is at work. All right. So that is how interfaces work. All right. There are more advanced ways to use interface. There are more better ways to use interface. There are more advanced ways to use interface. And one of the ways we are going to be using interface is going to be in our me contract, which will be doing in our next class. All together. All right. So let me run these example again. Let me run through it again. Let me just do a recap of what I've done so far and um, tell us what I've done so far. All right, so I said that I created a contract. I call it counter. So what this counter does is to increment. All right. This for those persons that don't remember, this plus equal to is that I'm going to add one to count and I'm going to um save the result in count. All right, so if count is 1 and I'm plusing it by 1, all right, count to be equal to 2. You understand? So I don't have to get another output again. You understand? I'm going to just save the whatever answer back to count. So that's it with increment. So whenever I call count, it's going to be adding 1 to the balance of count. Whenever I call count, it's going to be whenever I implement the function increment, it's going to add 1 and it's going to always add 1 to count. It's going to always add 1 to the value of count. All right. So that's the contract. That's what we did here. All right. So you can go and play with it. All right, and have fun. Now, this interface, what this interface does is that wrote a function called count. All right. And so what this count does is that it gives us the output. You understand? It returns the value of our increment. All right. And then we call this function here increments. All right. We call the function increment. Okay. And then this increment is what is here. You understand? So these are a new function we created in the interface to return the value of this increment. All right. Good. So that's the function and that's the increment. Okay, so we created two functions to play the role of this function increments that we did here. And now remember that we did not create any state variable. You understand? So this is how to create functions in interface. All right. So having done that, we came here and then we created a different contract. So created a different contract and then we call in these functions and then we call in this counter. So we're calling this function of increments in our interface and then we call this count function from our interface. Now mind you understand, mind you, the same way in our other contracts where the reason why this thing is working very well like this, where we are not importing, is because they are all in the same file. So there's no need to import. All right. All right, there's no need to import. But um um when you are writing a different contract, like when you are writing a contract, let's say this contract is outside um how will I put this? They are not in the same location, like the way we imported in simple storage contract. Okay, you import. You are going to be importing. We are going to be importing our interface. All right, so we're going to be importing our interface so that in case in our next class we are importing interface, it will not be like but in our last class we did not import anything. Everything was just in one place. Okay, so the reason why we are everything is here is because everything is in one, we are doing everything in one contract space, in one environment. All right, so if you are creating different contracts, different files, your interface all together. So all together, so normally this is how it's going to work. This is how it's going to work. This normally if you want to write a contract, so normally this guy will be here. All right, this guy will be here. All right, as your interface. And so if you want to write another contract, okay, you can write another contract and then import this guy. Now your interface and the contract you are interfacing should be in one place. You get your interface and the contract you're interfacing will be in one place. You understand? But your contracts that you want to interact with, the new contract can be in London, can be in whatever. You understand? Your own is just to import that contract, sorry, that interface, and you're already interacting with the contract. That's the interface. That's the interface is interfacing. Understand? Like this interface counter now is interfacing this counter contract. All right. So this my contract can be in London and then can call this interface counter and then you can interact with your counter contracts. So that's how it actually works. All together. All right. So any question? Yes, Chidera. Chidera, I see your hand. Answer your question.
I thought I was talking. I said the line after the function of my contract. Can you try to explain it? I'm trying to process it, but it's not entering.
The line after
After yes, that the
this
next
one,
line and the next one.
this one
Yes, yes.
is almost see if you go back to your my storage contract. You're going to see similar similar something. Understand? What we are doing here is not new. It's not new at all. Understand? What we are doing here is not new at all. All right, it's not new at all. So, but I'll explain it. Okay, I'll explain it. Now, remember I don't know if I can remember, but just go back to our simple storage. You will see something like this. You go back to our simple storage when we are writing um um which of the contract is it? Storage factory. Yes, storage factory. You see something like this. But nevertheless, let me explain it. Okay, it's the same thing that happens here. It's the same thing that is also happening here. All right. So I think if I explain this one, it will suffice for this one as well. Okay. So this is what this interface is doing. It's saying this is what this syntax is doing. It said that we are you've gotten your inputs, no problem. You said that your input is going to be address. All right, so we are going to be using address for the counter, unlike this normal um contract that does not have any inputs. Here you are going to be using address as inputs. Now we said that counter, this interface counter is calling our interface. You understand? We're calling our interface by calling the name of our interface here. All right. The same way we are calling our simple storage in our simple storage contract, then understand. So that's it. And then we are saying that this guy is getting our input counter. Now remember that um this increment contract, the same way we did it in simple storage. I remember, I think I remember when we are writing function for store, that store function something you get. This guy, we wrote a function for store, Abi, and then when we are calling it in uh storage factory, I think we did something like um simple storage, Abi, the store, and then we put in the inputs. Understand? Let's call it like input. Let's call it input. All right. So we did something like this. I don't know if if you can remember.
Yes, sir.
Yes, we did something like this. So
Yes.
now what is this one telling us? This one is telling us that we are calling this simple storage contract, Abi, and we are calling this function. And this function is going to have these inputs, Abi.
Yes.
All right. So um similar things plays here. That's similar thing that plays here. Okay. So we are saying that we are calling our interface, and this interface is having this inputs. Okay. But this interface is using this increment function. All right. This is using this increment function. Now, where did we get this increment from? We got this increment from our function increment. And where did we get this increment from? We get this increment from our function increment here in this counter. You understand? So this increment is from this increment, and then this increment is actually deploying this function of this increment. So if this increment is the same with this increment, that means when we call increment in interface, in our interface, you get, is actually indirectly connecting to this guy. So it's going to be having the characteristics of the increment in our counter contracts. All right. So that's the dot notation here. It's telling that we are calling this function increment here. It's actually this function technically we are calling, not this function. All right. Because if we call this function, we calling this function is actually calling this function. Are we together? We calling this function is actually calling this function. And so when we say increment, we are saying that we are calling the increment function in interface. You understand? And we are saving, we are getting this number as if we are getting the number from our increment in interface. Sure you understand? All right, so that is what it is. That's what it is. That's what it is. That's what it is. Now, another thing we have to note is that remember that the increment here is working with a particular data type. All right. So when we are working with the function, we should know that the function we are using here should be of a particular data type. I don't know if you get, the returns should be of a particular data type. Now the counter here is that we are returning uint. Okay. So whatever input our input will be, our output is always going to be what? Units. Then it's going to return units. We are returning units. You understand? But our input is what? Is is another data type address, but our output is always going to be what? Units. Is that because of our counter here, else is going to flag an error. If we return something else, it's going to tell us that we don't understand what you are returning. What you are inheriting is different from what you are bringing to the table. Okay, so that's something we should also put into consideration. But when you write something like this, a function name and a bracket, it's you're actually telling us that you are calling in that bracket. So what's this line? What I've been saying since is just explaining this particular one line of code. The interface, the input, and we're using this input to call the increment function. Any other question? All right. So in the absence of no question, let me just quickly run through what I have said today. What we've done today. We talked about Oracle. We said that um, oracles are and mechanisms that makes our contracts that gives our contracts the ability to be hybrid in nature. Hybrid in the sense that can have the characteristic of an off-chain and on-chain. Can have our contract can have on-chain and off-chain characteristics at the same time. Understand? So that we can do things like NFTs, we can do things like sports betting, we can do things like things that are not on the blockchain. We can bring them into the blockchain so that the blockchain can have real world experience. Understand? And we said that naturally the blockchain cannot do it because of its deterministic nature. Okay, so we have to use an oracle so that we can bring these things into the blockchain. And we said that one oracle that can do that effectively is Chainlink. And then we said that Chainlink is a modular and decentralized Oracle network, okay, that enables the integration of data. All right. Okay. It also enables external computation um, of chain data into our smart contracts. Okay. And we said that when smart contracts combines off-chain and on-chain data together, it becomes an hybrid contract. Okay. And so we also said that Chainlink has four main products. Okay, we have the data feed, and we said that the data feed helps us to um, collect real price data of assets, you understand, from exchanges, okay, into our contract. And we said that another of their product is verifiable random functions, which help us to generate random numbers. Okay, we said that these random numbers are generated from the off chain, but they are immutable. That means they cannot be manipulated. All right. Sorry, they cannot be manipulated. Sorry. All right. I mean to manipulation. All right. So we also said that we have automation, okay, which um help us to the types as nodes that watches our contracts. So when a specific event is triggered, you understand, they swing it to action. You understand, until which the the contract is the action is called for. All right, so the last one we talked about was functions, chaining functions. I would say like chaining functions help us to call APIs on our blockchain environment, on our decentralized environment. All right. So okay, and we then said that in our next class we're going to put that into work, and then we're going to be making use of it in a real project, and that's going to be our funding project. Okay, so what else? And lastly, we talked about interfaces. I would say that interface are are um contract like they are like how will I put it? I've forgotten the words. Um I'm going to use. Okay, so interface helps us to interact with contracts without importing the actual contract itself or copying and pasting the contract in our contracts. All right. It also it helps to bring contracts together in one particular environment, and then so that the two contracts can interact within them among themselves. Okay, so we said that interfaces can not inherit contracts, but interface can inherit other interface. And we said that interface are external. So when you're using your interface, your functions should be external as well. Said you can't call state variables, you can't call constructors, you can't create constructors um, on in your um, interface. Okay. Okay, so what else? And then we said that interface are of external type. All right. Okay, so that's it. And also said that we're going to see how we also implement it in our contracts on me. Okay, let me put up the contracts. See what. All right, so this contract we're talking about fund me. All right, so so that we can say here that so I can say here that message dot value should be above minimum USDT. You get it? All right. So all right. So that we can say that our minimum value should be above the minimum USDT, and we said that the minimum USDT is $5. Okay. Okay. So it should be greater than or equal to. So this one should be greater than or equal to. All right. I don't like all these plenty things. All right. So it should be like this. All right. So this is what we want. We want our contracts to be you can't put anything less than $5. You can't give support somebody less than $5. So in our next class, we're going to be seeing how we're going to see how we're going to implement this real data into our contracts. Okay, and now we're going to use interface in our contracts. All right. Okay, so no assignments tonight. For those of us that did my assignments, I saw what you did. Okay, although I only saw the first one that the class rep sent to me. I've not really entered um Telegram since afternoon, so I don't know if she has sent others something, but I've seen the ones that she sent. Good works. Okay, kudos. All right, so that was going to be it. Now next class expects um nice assignments, but for now let's enjoy our week. Please go back and check um
Sir,
Sorry.
I want to ask a question. In that interface, can you please go back to the code?
Okay.
Yeah, you said you can't use a state variable. That's uint public count. Is it not a state variable?
Yeah, you are using a state variable in your contract. You are not using it in your interface.
Okay.
Yes.
Okay. Second, please drop this code on the group chat. Thank you.
So, um, okay, 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 okay. So, what else? 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 So that's it. Please go and read on Chainlink protocol. Go to the website chainlink.com. Go to dev and and read about it. Okay, you don't have to understand everything. You don't have to understand everything, but it should just be in the back of your mind. But you don't have to understand everything. All right. The more we make use of these things, the more it start getting clearer. All right. The more we make use of it, the more it starts getting clearer and clearer and clearer and clearer. But if you've not been confused once, um, you might become confused very late. All right. So be confused now, and while we go on it unfolds, then you just let it slide and you didn't attack it. And then later on, when we start doing something on it, it's becoming confused. It's not going to be nice. All right. All right. One more time. Any question? Okay. All right. So let me stop recording. So